Okay, so we were in the middle of our torque ladder question. We had already done the sum of the forces in the x, and we found that the force of friction on the ground equaled the normal force of the house. We did our sum of the forces in the y, and we actually got a value for the normal of the ground. And we're now about to do our sum of the torques. Okay, and so I had just suggested pick your pivot point down here. And you might be like, no, because if I do that, I get rid of the normal of the ground torque force, which I know. But trust me, you want to pick it down here. And so when you do, this goes to 0, and this one goes to 0. Okay, and so now when we figure out positive and negative, lie your writing utensil along the length of the thing that's rotating. The normal of the house is going to push it up like that. The two weights are going to push it down this way, right? I'm going to push it like this. So the normal of the house will be positive torque, and the other two will be negative torque. So it'll be R normal of the house, F normal of the house, sine theta normal of the house, minus R of the person, FG of the person, sine theta of the person, minus R of the ladder, FG of the ladder, sine theta of the ladder equals 0. Now note, these two are weights, but the normal of the house has nothing to do with the house's weight, but it's the weight of the person and the weight of the ladder. All right, so what do we know? We can find our R's. I think we were given an angle too, right, weren't we? Yeah, 60 degrees. I just didn't mark it in. We can find our R's because we have the lengths. We can find our thetas. We know the masses. The only thing we don't know is this F normal of the house. So take the other terms to the other side. Well, they'll become positive. R of the person, really that's M of the person G, sine theta of the person, plus R of the ladder, M of the ladder G, sine theta of the ladder. And then you're going to divide by R normal of the house, sine theta normal of the house. This time, sadly, none of the angles are 90, so they all stay. And so now we just need to fill our numbers in. So, house. F normal of the house is equal to R of the person was 3/4 of the way up a 5-meter long ladder. So that should be 3.75 meters. Mass of the person, 60 kilograms. 9.81 meters per second squared. And what is the angle between the R and the F? It's this angle, it's this angle up here. It should be 30 degrees. So sine of 30 plus R of the ladder, 5-meter long uniform ladder, R should be 2.5 meters. The ladder itself was 10 kilograms times 9.81 meters per second squared, and the angle for the weight of the ladder, again, is going to be 30 degrees, so sine of 30, divided by R normal of the house. Between the pivot point and where the normal of the house is, it's the full length of the ladder, it'll be 5 meters. And what is the angle between the R, which is here, and the F, which is here? It's this angle, which is the same as the one at the base. It's going to be 60 degrees. So don't get lulled into a false sense that once you find one angle, you know them all. They are not necessarily the same. Now, I hate to tell you this, but you somehow have to type all of this into your calculator correctly to get the right answer. And if you do, you should get, and you might want to pause me to try it, 283.1903 newtons. That's F normal of the house. But you might be saying, how the heck does that help me? Well, it helps me because F normal of the house is equal to the friction on the ground. So this is also friction. So I have the force of friction on the ground, and I have the normal force on the ground, and I know friction is equal to mu Fn. And so to find the mu of the ground, I need both the friction and the normal force on the ground. I now have them, so I can rearrange. It's going to be friction divided by Fn of the ground. So it's going to be 283.1903 newtons divided by that 686.7 newtons. And when I do this, I get a mu of 0.412393. Okay, so it was all right that these canceled out because the normal of the house is equal to the friction of the ground. So I still end up getting the friction on the ground. I already knew the normal on the ground, and those were the two things I needed to find the mu that the question asked for. Okay, so now it's your turn to try some of these, and these will be your homework, okay? Some of these that I'll tell you on this sheet.